Hello everyone and welcome back to another math video. Today we're going to be looking at how do you match an exponential function with its graph. So similar to these problems that you see up on the screen here. Just a reminder, this is the normal version of this lesson. If you'd like the speedrun version where we go pretty quickly, I will link that in the description below. All right, your Ricasso Recap starts now in 30 seconds or less. Here's what you need to know before you start this lesson. Firstly, you should know how exponents work. And then you should know how negative exponents work. And lastly, you should feel comfortable with graphing coordinates. If you would like a refresher on any of these three topics, I will link videos in the description below. Please go watch those before you start this lesson. All right, new lesson starts now. Here we go. So I'm going to do a little graphing here to show how this works. So every exponential is in the form of y equals a number, parentheses, another number, close parentheses with x in the corner. Every exponential function looks like this, okay? And we usually call this number a, this number b. And so what I've done here is I have graphed an exponential function with just some numbers thrown in there, okay? We're just going to sort of throw these in here. And now what you can see I'm going to do is we're going to change only the number in front of the parentheses, and let's see how that affects the graph. So here is when I change the 1 in the front of the parentheses to a 2 well, you can see that sort of moves the graph. Okay, let's see what happens with the 3. Seems to move the graph again, and with the 4. Okay, and in fact, if we zoom in a little bit here, what we can actually see is that the y-intercept is changing, okay? And the y-intercept is always the number that's in front of the parentheses, right? Red graph, 1, hits 1. Blue graph, 2, hits 2. Green graph, 3, hits 3. Purple graph, 4, hits 4. All right, so the number in front of the parentheses is always the y-intercept. Now, so we said the a value is the y-intercept. What happens if we change the number inside of the parentheses? Let's move this a little bit. Okay. So here, here's what we start with. Okay, 1 to the x. And now let's change the number inside the parentheses. Keep the number in the front the same. All right, so if we change it to a 3, all right, the y-intercept doesn't change, but now it looks a little bit steeper. All right. What happens if we change it to 4? A little bit more steep. Okay. And we call this type of graph an exponential growth function because it's going up from left to right. Think of it as if you were riding a roller coaster from left to right, you would be going uphill on the roller coaster. Okay, so this is exponential growth. Now something curious happens though. What if we put a decimal inside the parentheses? Okay, so now instead of going up from left to right, we're going down from left to right, and this is called an exponential decay function. All right, but what made it decay? Was it the decimal? Let's try another decimal. Okay, that's another decay function. Let's try another decay function. Or with a decimal, I'm sorry. So that decimal gives us the growth function. So what changed? Well, you can see that with these two decimals, 0.1, 0.5, both of those numbers are between 0 and 1. Okay? So here's what I mean. If the number on the inside of the parentheses is between 0 and 1, then it will be an exponential decay function. It'll go down from left to right. If the number inside the parentheses is bigger than 1, then it will be a growth function. Okay? All right, we're going to use this info now. Let's take a look. So on this, you have 4 graphs on the right, and then you need to match each of these to the right graph. All right? And there are 4 sort of ways to check, and you should go in order here. So you should start with the y-intercept. Okay, and we said the y-intercept is the number on the outside of the parentheses. So the y-intercept, and remember, this is the name of the function. This is k of x, This is J, G, N. Okay, those have sort of nothing to do with, they're just the names, right? So for function k, the y-intercept, the number in front is 1/3. And we can go down the line here, 4, 3, and 3. Well, already we can start to eliminate and put some right answers, right? Because J is the graph with a y-intercept of 4. Well, look at the graphs on the right. Which one has a y-intercept of 4? It's this one, right? So J goes here, okay? Let me clean that J up. J goes here because it's the only graph with a y-intercept of 4. So boom, done with that one. Now let's look at K. Can we find a y-intercept of 1/3? That would be between 0 and 1. Well, there's only one graph that has a y-intercept between 0 and 1, and that would be in the bottom right corner. So this is K. Boom, done with those. Now, we have a tie here with the y-intercept between G and N. So we need to now look at the growth or decay. And we said growth or decay depends on what is the number inside of the parentheses, okay? We said if the number inside of the parentheses, which is b, if it's greater than 1, it will be a growth function. If it's between 0 and 1, then it's a decay function, and it'll go down from left to right. So let's look at n first. N is bigger than 1, so it's a growth function. So it should be going up from left to right, and it should have a y-intercept of 3. So you've got this graph and you've got this graph. Bottom left, top right. Which one is a growth function going through 3 as a y-intercept? Well, that would be the top right corner, right? So this is n, right? This is a growth function because it goes up from left to right. And process of elimination, this has to be g then. Okay, this has to be g. This is a decay function going through a y-intercept of 3. So that matches up. And, oh, I should have, so this was growth. I'm sorry. Let's do D for decay, G for growth. Okay? Now let's spell it out. Decay, growth. And for these, you didn't have to do it because they were already used up. And you don't need to do anything else because you've found out where the correct graph is. All right, here is our cool clock for today, which means that it is time for you to practice what you just learned. Go ahead and pause the video and try these 2 problems on your own. And when you're ready, you can unpause the video and we'll check your answers. Okay, now that you've had time to work these problems, let's check your solutions. Okay, for the first problem here is the table filled out and the correct answer. And for the second problem here is the table filled out and the correct solutions. All right, last type of problem here. So when you look at these problems here, you might see something weird, which is they have a number, for example, this Q has a number inside the parentheses, but no number outside the parentheses. And that's because it's there, it's just invisible. There's an invisible 1 there. Okay, so we're going to write it in. Same thing with M, there's an invisible 1. For N, there are no parentheses, but this 2 is what goes in parentheses, and then there's an invisible 1 in the front. And for P, there's an invisible 1 in the front. Right, so if you don't see the parentheses, the 1s, okay, if it helps you to write them in, just go ahead and write them in. And now we can do what we did. All right, so y-intercept, 1, 1, 1, 1. Okay, that didn't help things. Let's try growth and decay. So Q is a growth. M is decay. And I'm sorry, I misspoke. Q is not growth. Let's try that again. Smaller than remember, we're looking at the number in the parentheses. Inside of the parentheses, this one is growth. And this one, all right, 4 over 3, you have to be careful. 4 divided by 3 is 1.3 repeating. So that's bigger than 1, so this is growth. All right, we still can't eliminate any answers here, okay? So now, this is something new. The next step is to plug in x equals 1. And what I mean by that is, let's look at Q down here. Q of x is 1 times 1/2 to the x power. And when I say x equals 1 is the next test, we're going to replace the x with a 1. So we're going to change the x to a 1. And now, okay, 1/2 to the 1 power is 1. And so this is 1 times 1/2, which then equals just a half. Okay? So when x equals 1, we're getting a y value of 1/2. Okay? It should hit 1, 1/2. Should hit 1, 1/2. So let's put that in our table. 1 gives me 1/2. And let's do that process for all of them. Let's not do that. Let's delete this. Okay. So plugging in 1 for m would give me 3/4. Plugging in 1 for n would give me 2, so 1, 2. And plugging in 1 for p would give me 1, 4/3. All right, we're getting closer here because let's look at n. N is the only one that hits 1, 2, right? So on your graphs, which one hits 1, 2 exactly? Well, that would be right here. Okay, no other graph hits 1, 2 exactly. And so this is n. This is n, and we can cross that one out. Well, now that helps us eliminate as well, because now p is the only other growth function. So which other function is a growth function? Well, this is this top left corner grows, right? From left to right. So this is p, because again, there was only one other growth function. All right, now these, for Q and M, these are close, right? 1/2 and 3/4 are kind of close. It's kind of hard to tell from the graph. So now let's do our last test, which is plugging in -1. When you plug in -1 here, okay, and we should know about negative exponents already. Change it to a -1, okay? This becomes 1 times 2, which then just becomes 2. So when I plug in -1, I get 2. And that should do it, because -1, 2, which graph hits -1, 2 exactly? It has to be this one, okay? And so this is Q, and process of elimination, this has to be M. All right, so sometimes you have to use multiple tests over here on the left. Again, go in order always to figure out which graph is which. All right, time to practice. Go ahead and pause the video, try these last 2 problems on your own. When you're ready, unpause the video, and we will check your answers. Okay, now that you've had time to work these problems, let's check your solutions. Okay, for the first problem, here is the table filled out and the correct solutions. And for the second problem, here is the work and the final answers. All right, that is it for today. I hope you all have a good morning, good afternoon, good evening, and good night.